Okay, now let me demonstrate my emulation on the 11N to the ZigBee receiver. Here is a wireless router, which is TP-Link. Oh, this model, the TP-Link N750. And now I only plug in the one antenna because I think the one antenna is able to demonstrate the emulation working on 11N. And here is a receiver. I use a USRP running the ZigBee module, work as a ZigBee receiver, and it's connecting to the laptop. And now let me start the ZigBee module. And okay, now the USRP is working. You can see the LED light is on, so the USRP is working now. And here there's no packets received here because there's no signal is transmitted in the air. And now let me start the emulation. Here is how I control the emulation on the OpenWRT. Let me inject the packets. Now it's injecting the packets from the wireless router. You can see the LED is blinking, meaning that it's sending out a lot of packets. And you can see here the USRP receiver is actually receiving the packets. Oh, it's moving. So sometimes we can decode the whole packets, the whole frame correctly, and sometimes only the preamble is decoded. I set the length of the preamble to be 4 because I want to use the shorter 11 packets, and to eliminate the false positive. Actually, I use a very restricted threshold to tolerate the chip error, which and the threshold here is 7, which is more restricted than the default setting, which is 10. So the false positive rate is very low, and you can see that we can demodulate the preamble successfully. However, sometimes the data parts are gone, but we can see that in ideal case the received packet is 329112. But anyway, this actually shows that the emulation really works. And now let's see from the Wi-Fi receiver, let's see what is the received packets, whether the received packet is an 11 packet, whether the received packet is a legitimate 11 packet. So this screen, this monitor actually connects to the 11 NIC here. And now let me use the Wireshark to see what are the received packets from the Wi-Fi receiver side. Okay, now let's start the Wireshark. You can see that I inject a lot of packets from the wireless router into the air, and here is the Wireshark receiver. And let's stop here. And these are the packets, the injected packets. The length is very long because I need to use the long packets to emulate the ZigBee packets. So let's select one packet here. You can see that the information shows that it's an 11 packets, and the bandwidth is 20 megahertz. MCS is 6, meaning that these packets use the 64 QAM, and the encoding rate is 3/4, and the data rate is this. And apparently this is not 11G or B packets. And in my experiment, the center frequency is set to be 5 gigahertz because on this wireless router, only the 5 gigahertz radio chip can support our emulation. On the 2.4 gigahertz radio chip, the 2.4 gigahertz radio chip on this wireless router actually does not work so well. But I think this is enough to demonstrate our emulation can work perfectly. And the one interesting thing here I want to point out is, you can see that we almost send out almost 500 packets per second, or almost 300 packets per second. However, at the receiver side, we receive packet. We can only receive we receive almost 2 packets per second. This is because the scrambler seed on this wireless router cannot be controlled. But we know that the scrambled seed is determined because the scrambled seed increment by 1 for each packet. And actually, as long as we can receive the emulated packet from ZB successfully, we can actually determine what the next scrambled seed is. But in my experiment, I just assume that all the scrambled seed is the same, and then I send out the packets, send out the customized packets, and only one of the packets can be okay. Let me explain this. The scrambled seed is 7 bits long, so there is 128 different scrambled seeds, and because the scrambled seed increments by 1 for each packet, so for each 128 packets, there will be 1 packet can represent our emulated ZB signal, and all the other packets are actually messed up because the scrambled seed doesn't match our assumed scrambled seed. So that's why we send a lot of packets in 1 second, but we only receive 1 or 2 of them within 1 second, because only 1 or 2 of these packets matches the scrambled seed we assumed in our experiment. And I think this experiment works perfectly because you can see that the injected ZB packets can be received by the ZB receiver successfully, even though the packet reception rate is low. But you can see that the preamble part seems to be received perfectly. I don't really understand why, but it seems like but this actually shows that the emulation works well on the 11N. And based on this experiment and the codes, actually we can apply these to the multiple antenna scenario. We can use 2 different antennas and 3 antennas, and this mesh order can support up to 3 antennas, and I think this is enough for us to do the experiment.